Hello guys, welcome to Creative Learning with Aru and Athar. Today we are going to discuss another important concept in maths which is called fractions. So what is a fraction? Fraction is whenever we divide a thing into equal parts, then each of the equal parts is called a fraction. Like for example, we have a square, this square we have, and we have divided it into equal parts. 4 equal parts we have divided in. Now each of these equal part is a fraction of the whole. Right now we have not shaded anything or not. We are just telling you that each equal part is a fraction of the whole. Similarly, this triangle we have divided it into. Let's just draw one line here also. 1, 2, 3, 4, 5, 6, 7, 8. So we have divided a triangle into 8 equal parts. So each equal part is a fraction of the whole triangle. Similarly, I have a rectangle like this, and if I divide it into 5 equal parts, then each of these equal part is a fraction of the whole. So whenever a whole, or we can say the thing, you can also say a thing, is divided into equal parts, then each equal part is called a fraction of the whole. Then each equal part is called a fraction of the whole. Now if we talk about fraction, now let's take a look again at this figure. So this is a square, and if I shade this one part of the square, if I shade it out, this one part of this square, then how many equal parts were there for this square? We have the 4 equal parts were there, and out of which one part is shaded, right? Similarly, if we take for example this triangle, and if I shade out some parts of it like this, let's shade out this one and this. So I have shaded 3 parts out of 8 equal parts of this rectangle. So I will say I have shaded out 3 parts out of 8 equal parts. Similarly, for this rectangle, if I shade out like this, this and this, so I have shaded out 3 equal parts out of 5. So these are all representation of fraction. This is how we represent the fraction. If I talk about these fractions 1 by 4, 3 by 8, 3 by 5, then with the number which comes on top is called the numerator, and the number which comes on the denominator comes on bottom is called a denominator. Or you can also think of numerator and denominator as, the definition for denominator would be like the total number of equal parts, because as we know 4 were the total number of equal parts, or 8 were the total number of equal parts, or 5 were the total number of equal parts. So denominator is nothing but the total number of equal parts. Total number of equal parts is called the denominator. And what about the numerator? Numerator is nothing but the number of parts which were chosen. Number of parts chosen. Or you can say number of parts shaded or number of parts selected. Like here only one part was selected or shaded. Here 3 parts were shaded. Here also 3 parts were shaded. So numerator is something, the number of parts which are shaded or chosen or selected, and the denominator is the total number of equal parts. These are the two definitions for numerator and denominator. Numerator is number of parts chosen, and denominator is the total number of equal parts. Let's talk about fraction of a number. Suppose we have a number like 25, and I have to calculate the 3 by 5 fraction of it. 3 by 5 of 25. What is the definition of fraction? We know the definition of fraction now. It is when we divide a whole into equal parts, and the denominator indicates how many equal parts are there. So if I divide 25 into 5 equal parts, then each group will have 5. Let's suppose this is one group, this is another group, this is another group, and this is another group, and this is another group, and in each group there are 5, right? There are five numbers are there, 1, 2, 3, 4, 5 like this, and out of which I am selecting 3, because that's what the numerator is saying. So how many I have selected? I have selected 5, 10, 15. So I have selected 15 numbers out of that. So 15 numbers I have selected. So 3 by 5 of 25 is 15. This is how we get 3 by 5 of 25. 3 by 5 multiply by 25 we do, and we get we do it like this only. 5 times 3 we get 15. But here is how we get it. We divide 25 into 5 equal parts, and then from each equal part we select 3 equal parts. So we have selected 3. This is how we get the fraction of a number. Suppose we want to calculate 1 by 5 of 40. How do we calculate it? 1 by 5 of 40 is we divide the whole 40 into 5 equal parts. So each equal part will have 8. Here we have 8, here also we will have 8, and here also we will have 8, and here we will also have 8, and here also. So this is 8, 16, 24, 32, 40. Now out of these 5 equal parts we are selecting 1. So, and this has 8 numbers inside. So we can say that 1 by 5 of 40 is 8. Let's take a look at a word problem based on the previous concept, fraction of a number. Anna finished 1 by 4 of her homework having 12 questions. How many questions have she answered? It's a very simple word problem. There were total of 12 questions in her homework assignment, and she have answered 1/4 of it. So how many questions she have answered? 1 by 4 of 12. How do we calculate 1 by 4 of 12? We divide 12 into 4 equal parts, and each equal part will have 3 parts, because if we divide 12 into 4 equal parts, then each equal part will have 3 parts, 3 questions. If we say like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12. So we divided the 12 into 4 equal parts, and now out of which 1 part she have answered, you can say. So how many questions she have answered? She have answered 3 questions she have successfully answered. So 1 by 4 of 12 is, also we know that is 3. This is how we get the 3. All I'm trying to explain here is how we get the value. It's very simple to calculate, because whenever we want to calculate a half of a number, we just divide the number by 2, or we multiply it by 1 by 2. If we want to calculate 1/4 of a number, we can divide the number by 4 and multiply it by 1 by 4. So I'm all trying to explain it to you how we get to the answer. In Olympiad or in any other exam, you don't have to follow the complete process. You just have to do this step. 1 by 4 of 12. 1 by 4 times 12, and you can write it as 3 as easily as that. You should also know the reason how we got that. That's all I am trying to explain here. Let's talk about types of fractions. If I talk about the types of fraction, we can say there are like fractions, there are unlike fractions, and one category is proper fraction and improper fractions. Proper fractions and improper fractions. First we'll take a look at like and unlike fractions and their operations, and then we'll talk about proper and improper fractions. If I talk about like and unlike fractions, like fractions are those fractions which have the same denominator. Categories of fractions which have the same denominator, we call them like fractions. And fractions which have a different denominator, we call those fractions as unlike fractions. Like, for example, so this will have different denominators, this will have different denominators. So like fraction would be like 1 by 5, 2 by 5. If we take these two fractions, then both of them have the same denominator, so this will be like fraction. If I talk about 2 by 3 and 1 by 4, their denominators are different, so they are unlike fractions. And there are plenty of questions we can also do, like suppose I give you 3 fractions, you have to tell whether or not they are like fractions or they are unlike fractions. Like for example 3 by 11, 3 by 13 and 3 by 10. So now we can see their denominators are different. So these if their denominators are different, so they are unlike fractions, right? Similarly, if I gave you an example like 5 by 17, 11 by 17, 9 by 17, they are having the same denominator, so they are like fractions. So we can say they are like fraction. So all you have to remember here is fractions having the same denominator, they are the like fractions, and if fractions have different denominators, then they are unlike fractions. Let's talk about proper and improper fractions. So what is a proper fraction and what is an improper fraction? Proper fraction, we can say any fraction in which numerator is always less than the denominator. In case of proper fraction, numerator will always be less than the denominator. Numerator is less than the denominator. But in case of improper fraction, numerator will always be greater than or equal to greater than or equal to the denominator. So this is the basic difference, or we can say the definition for proper and improper fraction. Like for example, if I talk about this rectangle, it is divided into 8 equal parts, and if I shade out 3 parts out of it, suppose, so I have the fraction of shaded part will be equal to 3 by 8. So here the numerator is less than the denominator 8. So this is a proper fraction. If I talk about this rectangle, it is divided into 5 equal parts, and I shade out 2 parts like this. So here the here also fraction of shaded part is 2 by 5, and it is a proper fraction, which means in case of proper fraction, the numerator will always be less than the denominator. This is the definition for proper fraction. What about improper fraction? Improper fractions are those cases in which the numerator is greater than or it is equal to the denominator. Like for example, if we combine these 3 figures, here the shaded part is 4 by 4. It is divided into 4 equal parts and all parts are shaded. It is divided into 4 equal parts and all parts are shaded. And here 4 equal parts, 1 part is shaded. So we can say the fraction of shaded part is, in this case, 1. 4 by 4, if we say it is 1 plus 1 plus 1 by 4, or you can say 2 whole 1 by 4. You can say 2 complete figures are there and 1 by 4 is there. This is a mixed fraction, and if I convert it further into, like if I write it like this, 4 4 8 plus 1 9, 9 by 4. So this is 9 by 4. You can say it like this. Let's go by like this. 9 by 4. 9 by 4 is in this case numerator is greater than denominator. So this is an example of improper fraction. Numerator will be greater than denominator. And here the you can also write an improper fraction in mixed form, because you can see here it is 2 complete figures are shaded, so we can write 2 whole and 1 out of 4 is shaded. So this is how the mixed fraction is written. We'll cover mixed fraction in next part. Let's talk about mixed fraction. Mixed fraction is nothing but a combination of whole and a proper fraction. So mixed fraction is a combination of whole and proper fraction. Like for example, if I take, let's say I take 3 triangles like this. It is divided into 4 equal parts. Similarly, I take another triangle and I divide it into 4 equal parts, and let's say one more triangle and divide it into 4 equal parts. This is completely shaded. This is also completely shaded. And here in this case, I shade out 2 parts like this. So this is completely shaded. 2 parts are completely shaded, and 1 part, we can say 2 by 4 part of is shaded. So we can say 2 by 4, 2 whole and 2 by 4. 2 by 4 is a proper fraction because the numerator is less than the denominator. So a mixed fraction, we can say, is a combination of whole and proper fraction. We can say that improper fractions can be expressed as mixed fractions. For example, if I take these fractions like this, 4 by 4, here it is 4 by 4, and here it is 2 by 4, right? And we sum it up all, then what will I get? I will get the denominator as 4, and 4 4 8 plus 2 10. 10 out of 4. Numerator is greater than the denominator, so it's an improper fraction. So this is an improper fraction. So and this is also 2 whole 2 by 4. So mixed fraction, this is the mixed fraction and this is the improper fraction. So we can say improper fraction can be expressed in the form of a mixed fraction, or a mixed fraction can be expressed in the form of improper fraction. How we convert these two we'll see later, but we can say that an improper fraction can be expressed as a mixed fraction and vice versa. Let's talk about equivalent fraction. Take a look at these 5 figures, and in each of these figures I have written down the fraction of the shaded portion. Here the fraction of shaded portion is 1 by 2. Here also the shaded portion is 1 by 2. Here the shaded pieces are 4 and total equal parts are 8, so 4 by 8. Here also 4 by 8. Here is 2 by 4. We are divided into 4 equal parts and it is 2 by 4. What we mean by equivalent fraction is this, that even though we have shaded the parts differently, we can see that if we combine the shaded parts in all the cases, we can see that is still half of the rectangle. Half of the rectangle is shaded, half of the rectangle is not shaded. Here we can clearly see the shaded part is half and half. Here if I bring these two shaded part up and these two unshaded part down, then the half of the rectangle is shaded. We can see that. If I change this figure a bit like this, suppose, we don't have to do that, but I'm just telling you how we can see that. If I move this row up, like suppose if we redraw this figure like this, then we can see the half of the rectangle is shaded and half is unshaded. Here also, if I draw this figure like somewhat this way, and I shade out this part, I am bringing this part here, so I have shaded this. This is already here, I bring this part here. So this is half of the figure, half of the rectangle we can see is shaded. And here also, if I bring this part here, then this in this case also it will be shaded here. This was already shaded, this is shaded. So now we can draw this figure in a this way here. So as we can see from all of these figures that half of the rectangle is shaded. So we can say all of these fractions, all of these fractions, they are equivalent or they are equal. Two fractions are said to be equivalent when they have the same value. By same value, I mean that the numerator and denominator in the simplest form will be equal for all of this. Like this is 1 by 2. If I simplify it further, we can simplify it further. So if I simplify it further, I will get 1 by 2, which will be equal to this. So equivalent fractions in its simplest form, a fraction in two fractions are said to be equivalent if both of them in their simplest form have the same numerator and denominator. This is what I mean by equivalent fraction. As we can see also in the example, when I write this, in all these 5 rectangles, half of the rectangle is shaded. So whatever the number represents, whatever the fraction they represent, they are also will be equal. How do we find the equivalent fraction? In order to find the equivalent fraction, what we have to do, we have to multiply the numerator and denominator with the same value. Let's take an example for this. Suppose I have a fraction, let's just say 2 by 3. I have a fraction 2 by 3, I have a fraction, and I have to find 3 equivalent fractions for this. How do I find 3 equivalent fractions of this? I will multiply the numerator and denominator. Suppose for first time I multiply the numerator and denominator by 3. I multiply the numerator by 3, I multiply the denominator by 3. So here I will get 2 times 3 is 6 and 3 times 3 is 9. So this is one equivalent fraction of 2 by 3. Similarly, if I do for 2 by 3, I multiply by 4 and divide it by 4. So 2 times 4 is 8 and 3 times 4 is 12. So this is also one equivalent fraction of 2 by 3. Similarly, if I do by 5, so how do we find the equivalent fraction? We find the equivalent fraction by multiplying the numerator and denominator by the same number. All we have to do is, if we have to find any equivalent fraction of a given fraction, we multiply the numerator by one number and by the same number we have to multiply the denominator. Let's talk about how do we reduce a fraction to its simplest form. If I talk about a fraction and I want to reduce it to the simplest form, let's say for example I have a fraction like 32 divided 20. Let's see, this is a fraction we are given and we have to convert this fraction into a simplest form. We can say a fraction is in its simplest form only when both the numerator and the denominator have only 1 as their common factor. So right now if I see like this, 32 and 20 have more than one common factor. Suppose if I write right now the factors for 32, it will be 1 times 32, 2 times 16, 4 times 8. I think that will be also the factors are 1, 2, 4, 8, 16, 32. If I go for 20, I will write 1 by 20, 1 times 20, 2 times 10, 4 times 5. So here we have the common factors as 1, 2, 4, 5, 10 and 20. So right now if I look here, I will see that it has more than one common factor. It has 4, 1 and 2. 1, 2 and 4. These all three are the common factors for 32 and for numerator and denominator. And if we only say the fraction is in its simplest form when they have only one digit 1 as the common factor. So let's divide this by 4. If we divide it both the numerator and denominator by 4, 32 divided by 4 is 8 and 20 divided by 4 is 5. So 8 by 5. Now if I do again factors for 8, which will be 1, 2, 4 and 8, and for 5 it will be 1 and 5, then I will see, suppose for 8 the factors will be 1, 2, 4 and 8, and for 5 the factors will be 1 and 5 because 5 is a prime number. So we can say that the only common factor between them is 1. So we can say this fraction is in its simplest form right now. 8 by 5 is the simplest form for this 32 by 20. So in order to find the simplest form of a fraction, we can also see that 4 is the highest common factor here. 2 is also a common factor. We can divide it by 2 also if we want, but 4 is the highest common factor, HCF. So in order to find the simplest form of a fraction, we have to divide the fraction by its HCF. When we divide it by HCF, we directly get the simplest form. Because if we have divided this fraction by 2, 32 by 20, if I divided by 2, then I would have gotten 16 by 10. But right now it's not in the simplest form. We have seen the simplest form is 8 by 5. So if I divided by I divided by 4, then I will get the simplest form directly. So in order to find the simplest form for any fraction, we have to divide the fraction by its highest common factor, that is HCF. Then we can get the simplest form directly. I hope up till now the fractions have been clear. We have covered the equivalent fraction, we have covered the definition of a fraction, and we have also covered how do we calculate the fraction of a number. In the next part, we will cover the operations on fraction and the comparison of fraction, addition and subtraction of fractions. That's one operation that we have to cover, and also how do we compare the fractions. Those two topics we will cover in the next lecture, that is tomorrow. And I hope you like the video. If you are liking our content, do subscribe to our channel, and please share the content with your friends so that they can also learn. Thank you for watching. Have a great day.